Okay, what up YouTube? In this video, I'm gonna hopefully show the process of going from Fusion 360 to actually milling out carbon fiber using a CNC machine. This video is mainly gonna be a reference for me because it seems like I don't mess with my CNC machine enough to be able to remember how to do things. So I'm hoping that I can just document everything in this video and then I can reference it later on when I go to machine something out. And hopefully it'll help other people. There really isn't too many videos showing the complete process. So right here I'm in Fusion 360 and I have my model that I made up of my Questor frame, and I'm calling this the version 3. Today, the version 1 I never made, version 2 I made, and today I lost it in a pond, and I was planning on making another one, but I pretty much don't have a choice now. I had to make another one. I did make some changes to make it a little more reliable, just minor changes, and I'm still experimenting with the hole tolerances. And tell you the truth, it's been a while since I kind of finished this model. I even forget what I settled for the hole tolerances. But yeah, still kind of working through that process. And on the top plate here, I cut this design in the back. I don't know if I'm going to regret that or not. The other Questor frame I made had a solid top plate, but I figured I'll cut it, and then if I break it, I just know that that's too weak of a point, and I'll make the next one solid. And my workflow in Fusion 360 is really bad. Maybe someone can comment better workflow. The weird part about this whole process is, even though I had the model in Fusion 360, it seems like the only way I know how to do it is to export it and then re-import it in order to mill it. So let's go ahead and get right into it. So the first things we're going to do is we're going to do the top and bottom plates. So basically what I'm going to do is I'm going to click the top plate here, and I have my bodies all labeled. So if I go, where is it at? Oh, I messed that up. So I messed this model up. Somehow I combined all the standoffs to the top plate. Let's see if I can somehow do this without. You see, I already messed up my model. Let's see. Somehow combined all the standoffs together. I wonder at what part did I do that. But I think I can still get the contour of the top plate. Let me do this. Create sketch. And then create, project include, project, click on the top plate, and click OK. And then when we go down to sketches and take everything off, there we go. So now we have a sketch of just the top plate. So we hit finish sketch, and I'm going to rename it top plate for milling. And then I'm going to click on the sketch, and I'm going to save as DXFS and Questor version 3 top plate for milling. And then I'm going to do the same thing for the bottom plate. So if I click this, oh, that's PCB. I'm going to get all messed up. So hide that. Click that. That should come up as bottom plate. Yep. So click that bottom plate. Click create sketch. And the reason I need to, even though I have sketches labeled bottom plate, is when they're in 3D form, sometimes you end up modifying the contour of it, so you can't trust that. So we're going to do the same thing. We're in a new sketch on the bottom plate. I'm going to click the bottom plate. I'm going to project that onto the sketch. And then if I cancel everything out and hit finish sketch, and I hide everything except for that, there we go. We had the bottom plate for milling, so I'm going to just rename that. Rename bottom plate for milling, and we're going to export that as DXF. Bottom plate for milling. Like I said, my workflow in Fusion 360 is not the best. Okay, once we save that, we're going to create a new design, and what we want to do is we want to insert those DXFs. So we want to insert it what's a good plane? I got my planes all mixed up. Right there, top. So we want to insert it onto that plane, DXF file, bottom plate for milling. And then what I'm going to do is I'm going to just keep it in the positive axis. Just like that. Okay, and we're going to do the same thing. We're going to insert DFX. We're going to do top plate for milling. And we're going to do the same thing. We're going to go up here. How close can we get them together? We want to make sure we got 2 millimeters in here. We'll do inspect, because the bit I'm using is going to be a 2 millimeter bit. Oh. How do you do inspect? That's 4 millimeters. Okay, so that's plenty. We can actually move it closer to. Should we move it closer? Try to save some. Oh, too late now, huh? Okay, well that's good. I don't care about wasting material. Okay, and then just to make things a little easier, I'm going to extrude both of these. Uh-oh, we lost the. Let's go here. Okay, so we're back. I don't know what that was all about. I ended up having to modify the file after I brought it in. It has something to do with, I created this using the one side using a mirror effect, and when you do that, apparently it doesn't like saving it to a DXF, but I have no way of explaining that. So anyway, I have this set up with the bottom plate and top plate next to each other, and I actually made it so that they're 2.5 millimeters apart. So that should be good. The milling bit is 2 millimeters, the one that I'm using. So what I'm going to do now is I'm going to select both of them, and I'm just going to extrude 1.5 millimeters, which is the thickness of the material. So I have this model by itself with both plates side by side, 1.5 millimeters tall. Okay, so once we're done with that, let me go ahead and save this. We're going to call it Questor V3 plates for milling. Okay, we're going to hit save. Okay, what we're going to do is we're going to switch from design to manufacture, and we're going to set up, create a new setup, and for machine, I already made this machine, and just to document the information on the machine. It wasn't that hard to input. I think I just selected a generic machine, YXZ axis. I put in the build size, 110, 400 by 300. So the X, Y, and Z is messed up, but apparently this doesn't, this works. So I don't know how I set that up. Okay. So we selected the machine. It loaded the machine, operation type milling, orientation, model orientation, origin. So we want to, this homing origin, we want to put it in this corner. So that's going to be our 0 origin. And for the material, I just put it to relative mode. Side and top offset. We want to get rid of that because we want side offset is fine for 1 millimeter, but top is really what matters. We want it to be the same thickness, since we know that we're cutting 1.5 millimeter stock. But yeah, having this 1 millimeter, all that's going to do is going to bring the cutting in 1 millimeter. And actually, maybe I'll do 2 since my bit is 2 millimeters wide. But definitely the top and bottom offset we want 0. And then I think everything else is going to be good. Oh yeah, somebody online said that this matters, but I think I might have already inputted it on the machine setup. So we're going to hit OK. Okay. And now we're set up. So once we have it set up, we want to go to 2D contour. Okay, so for tool, we want a local library. I already set up, this is my bit. Now can I edit this? Yeah, so I got these bits off of Amazon. They're 2 millimeter, 1/8 inch shank, and I just put the description in there. I already have this all set up. You want to go through this. Okay, so feed rates. So I got my bits and my feed rates. I consulted Pat Regan. I'll link his YouTube channel in the description. He has a blog post about cutting carbon fiber, and that's why I reached out to him. But when I reached out to him, the information he gave me through email was different than his blog post, and he said he was going to update his blog post, but he never did. So I'll just link his YouTube channel, not his blog post, but he's the one who recommended the 450 millimeters per minute feed rate for cutting, and then plunge is 100. And my machine does not control the spindle speed, so you're pretty much putting this in here to help Fusion 360 do calculations, but we don't really do calculations. We just put in the feed rate manually. And oh yeah, no coolant disabled. And post-processing, it's been a while, but anyway, that's what when it cancels, I don't change anything. So we want to use this 2 meter bit, select, coolant disabled, and now we just want to skim through these tabs, and I have notes. So basically, we're not going to change any of these settings because that's for the tool. So we go to the next one, and the next one we're going to select our geometry. Now the thing is, as you're selecting the geometry to cut out, I'm gonna have it go and process it so it cuts the geometry out in the same order that I select it. So it's kind of kosher to drill all your holes first. So that's what I'm going to do. So I'm going to start from the bottom here and just select, and I'm selecting the bottom side of all the material. So we're going to do all the holes first. And hopefully I designed this so that all the holes can be cut with a 2mm bit. The first design I cut for the Vista unit mount on the top plate, I used smaller holes and I had to use a 1.5mm bit, so I had to do a tool change, which wasn't that big of a deal. But I realized that that was kind of overkill. It wasn't really needed. So we're going to cut all the holes first. Okay, once we finish cutting the holes, we want to then cut the other stuff that's not holes. So these battery strap slots. And then once we finish that, we want to cut out the whole object. Okay, so we have everything selected. And we are done with this tab. The next tab, our retract height. I believe this was machine materials. Now what I am going to do is I'm going to drop this top height to 2mm to help speed up the process. That's because we're cutting a flat plate. When it pulls the bit up 2mm, it's going to clear the material fine. And then what we're going to do is on bottom height, we're going to go a little extra 0.5 millimeter down into the material, because the way I have it attached with painter's tape, CA glue on the stock, which is what you'll see, there is going to be a little bit of deviation in the cut. So an extra 0.5 millimeter will make sure it cuts all the way through the first time. Okay, so now in this next tab, this preserve order, we want to check that. Preserve order will cut it in the same order we selected it. And then we want to enable multiple depths. And we want this maximum roughing depth step, we want it to cut a maximum of 0.5 millimeter each cut. So we're going to cut 0.5 millimeter deep, 450 millimeters per second. And that's it for this tab. And then just to let you know, I was experimenting with this keep tool down. So if you have this checked, when it's done a cut and it needs to go down for the next step, it'll just continue down. If you have it unchecked, every time it plunges, it'll go up before it plunges, and then it'll plunge. I guess that's to help clear the material. I'm going to leave it unchecked because I'm not in a big hurry, so I'll have it do that extra plunge. We're going to do a lead in, and we're just going to keep this stock. And that's pretty much it. So that's all the settings. We're going to hit OK. And spindle speed is larger. Okay, so the spindle speed I don't have set up right, so we want to ignore that. And okay, so it would not allow me to cut out these holes because it won't allow a 2mm bit to cut out those holes. So we are going to have to do a tool change on this job. I could change the file again, but I don't want to increase these hole sizes any more than I have to. So let's go and simulate this, make sure we have it right. You see how it's simulating it? It's cutting each hole. We'll speed it up. You see how it's raising the bit every time for the plunge? And it's doing 4 passes every time because it's a 1.5mm of material and then 0.5 millimeter finishing cut. Okay, so that job looks good. So we want to exit simulation and we want to do another 2D contour. And for tool this time, I do have 1.5mm bits. So in my library, I have these 1.5mm Kent fishtail bits. And I don't have the feed rate set right. So we're going to select it. And what we're going to do is I want to make sure I disabled. Okay. Cutting feed rate. I'm going to go 450. Lead in feed rate 450, 450, 450, and plunge feed rate 100. So I had to change that just because I didn't have my tools set up right. So that should be good. Okay, now we want to check the holes that it couldn't cut. So it couldn't cut. Let's see, we'll start here. This one. 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 Okay. And we're going to go to the next one. 10, 5. Change this to 2. And change this to negative 0.5. And then all these 450, 0. We want to preserve the order once again. We want to do multiple depth passes. We want to change this to 0.5. And then the final tab, we don't want to do keep tool down. I have these changed to, what, 1/10 of the width of the bit. I don't know if that's done on purpose or not. Okay, we're going to hit OK. It's going to render it, and then we're just going to simulate it again just to make sure it doesn't do anything crazy. Simulate. Okay. So exit simulation. Okay, so what we want to do is we want to export these now. So we want to hit create, right click, we want to hit create NC program. And then NC program. So I'm going to create a new folder just for this project to help keep me organized. 3. Select folder. And we want to name this, what do we want to name this? We want to name this top are plates, because it's both bottom plate and top plates. I'm gonna need the small holes. And we're gonna post. Okay, and then we're gonna go to this other one, create NC program, request over E3, file name, we're gonna plates, main cut. We're gonna post it. Okay, now we have successfully posted, so we're gonna go outside and go in the shop and start cutting this with a CNC machine. Okay, so what I do is I use an additional spoil board because I don't want to use the board that I have set up on my CNC machine. So I put down painter's tape on this sacrificial piece of MDF, coat the whole board, and I also coat the whole carbon fiber sheet with painter's tape. Then after that I put CA glue, and I also use accelerator. I have done this before without accelerator, but accelerator does really speed up the process. And I stick it on the spoil board. Now, what I'm trying to do is I'm trying to get it lined up square with the spoil board, because the actual spoil board on my CNC machine has lines in it to help line it up square. And what I'm doing here now is, after I secured it to my CNC machine, I just ran one axis of the CNC machine to make sure that the actual carbon fiber sheet was square with the CNC machine, so the CNC machine wouldn't accidentally cut off the carbon fiber sheet. Now what I had to do is I had to set up my XYZ home. So X and Y home is set up differently than your Z home. So as you remember, the origin we put in Fusion 360, I'm setting up the bit to be at that origin. Now I'm homing the Z axis. I do have a Z probe, but I don't think it works that well, so I just use a piece of paper to set the Z home. So now that I got everything homed, I can go ahead and start cutting. Now the first cut I did was for the 8 small holes using a 1.5 millimeter bit, and that's what's happening now. As you can see, I'm using the dust shoe and a vacuum cleaner, and I have no problems with dust. I do wear a respirator still, like a P100 respirator, but the dust is not a problem at all. Okay, so now that I'm done drilling those 8 holes, I gotta do a bit change, so I put the 2 millimeter bit in. Now, I don't touch the XY home at all. You got to leave the XY home the same. But since you change out the bit, you do have to do a Z home. So that's what I'm doing now, is I'm rehoming the Z axis. And it's very important you don't touch the X and Y home, or you don't shift the machine at all when you're doing the bit change, or you're going to have a failed machining. But after you reset the Z home axis, I can run the main cutting profile that will cut all the remainder of the cuts. And when I was getting into this, I was real afraid about dust, and I was trying to think about how to cut it under water. But I had a hard time figuring out how to easily cut carbon fiber underwater with a tray. But just using a dust shoe, and I have a HEPA filter in my vacuum cleaner. That's real important. There's no problem with dust at all. So the job's done. I vacuumed it off, and as you can see, I'm just lifting it. And as you can see, that 0.5 millimeter cut into the spoil board was perfect for all the painter's tape. Then I just take sandpaper around the edges, just to, there is a little bit of sharp edges. It's not too bad, but just take some high grain sandpaper and just run around the edges. And as you can see, I'm feeling it to make sure there's no places where you'll get cut. And that's it. Oh yeah, after I sand the edges down, I do wash the carbon fiber off to make sure all the dust is gone. But yeah, I'm just inspecting it, and that's pretty much it. Once you know how to do it, it's not that big of a deal to cut a carbon fiber frame. And now I'll never worry about being out of parts or out of bottom plates, not breaking a bottom plate, not being able to get it, because I make my own. I hope you enjoyed this video. Thanks for watching.